Hello everyone, myself S. Dilip, currently pursuing BTech final year in Electrical and Electronics Engineering at Theala Krishna Reddy Engineering College. Today in this presentation, I am going to present my paper which is going to publish in 7th International Conference on Computing Methodologies and Communications. My paper is titled as Reduced Device Count 9 Level Inverter for Standalone Applications. ICCMC 040 is my paper ID. Coming to the abstract of the paper, nowadays the use of inverters is increasing tremendously in many applications. Multi-level inverters give the accurate output waveform as near to sinusoidal waveform. This paper gives an overview of different types of multi-level inverters used. They are diode clamped inverter, flywheel inverter, cascaded H-bridge inverters. The proposed topology deals with the reduced device count 9-level inverter and its operation, switching sequence, and control technique used, and gives a review of output waveforms and total harmonic distortion, that is THD. It has many advantages over the conventional 9-level inverter, such as a less number of switches used, low THD value, higher efficiency, and lower price. This paper simulation results are verified in MATLAB Simulink software and reviewed on the output voltage and current waveforms. The main keywords used in this paper are multi-level inverter, cascaded H-bridge inverter, total harmonic distortion, that is THD, carrier-based PWM technique, asymmetrical multi-level inverter. Objective. Coming to the objective, the main objective of this paper is to introduce the reduced device count 9-level inverter for standalone applications. Currently, the conventional cascaded H-bridge is used, and the another objective of this paper is to reduce the number of switches and DC sources used in the conventional inverter to reduce the switching losses and improve the THD of the cascaded H-bridge inverter. An introduction to the paper is the inverter is an electronic device that converts the power from DC to AC. Also, similar to that, the multi-level inverters also have the same function, but the output can be modified as per our requirements. That is, the level of the output can be controlled with the many techniques. Thus, we can get the higher power and lower medium voltages output combinations as per our requirements. These multi-level inverters are broadly classified into three types, namely cascaded H-bridge inverters, diode clamped inverters, and capacitor clamped inverters. To control and get the output as per our requirements, many control techniques are introduced and used, such as sine wave PWM technique, space vector PWM technique, space vector control PWM technique, and selective harmonic reduction. The proposed inverter has various benefits over conventional inverters, including fewer devices, a smaller footprint, and fewer harmonics. With the support of multi-level structure, multi-level inverters with cascaded H-bridge are quite capable of achieving output voltage waveforms of higher quality and higher ratings. The efficiency of the cascaded H-bridge multi-level inverter increases when operating at high voltage with reduced electromagnetic interference. The most crucial step in a cascaded H-bridge multi-level inverter is harmonic removal, which can be accomplished using various types of modulation approaches. Here the existing topology is conventional 9-level cascaded H-bridge inverter. This figure shows the simulation circuit for the conventional 9-level cascaded H-bridge inverter, which have 4 H-bridge. Each bridge comprises 4 power switches and each DC voltage source. Here, the power switch used is MOSFET, and 16 switches are used, 4 DC voltage sources are used. The output waveforms, that is current waveforms and voltage waveforms, can be seen in the scopes. These are the outputs of the conventional 9-level cascaded H-bridge inverter. In the figure 1, y-axis represents 9-level inverter output voltage and time is represented on the x-axis in seconds. And in figure 2 and 3, represents the phase voltage and phase current of the conventional 9-level cascaded H-bridge inverter respectively. This is the THD waveform of the conventional cascaded H-bridge inverter. The THD value is 12.96 percentage for conventional H-bridge inverter. For M-level cascaded H-bridge inverters, the number of switches required can be calculated by using the equation 2 of M minus 1, and for number of DC supplies required is given by the M minus 1 by 2. These two equations are used to calculate the number of switches and DC supplies required. The mathematical formula for calculating the total harmonic distortion is given by the THD equals to root over summation n equals to 2 to infinity h of 2 power 2 by h1. This is the proposed topology, that is reduced device count 9-level cascaded H-bridge inverter. The figure shows the simulation circuit for proposed topology. It consists of two bridges, and each bridge consists of 6 power switches and one voltage source. Here total 12 number of switches are used and 2 DC sources are used. The switching sequence can be observed in the given table. For first level of the output waveforms, to get that level, the switches S1C, S1D, S1, S2B, S2D, S2 are in on position and the remaining switches are in off position. For level 2 in the output waveforms, S1C, S1D, S1 dash, S2B, S2D and S2 dash are in on position and remaining switches are in off position. Similarly, from the table we can see logic 1 refers to the on condition of the respective switch and the logic 0 refers to the off condition of the respective switch. Thus, by using this sequence, we can get the 9-level output voltage and current waveforms at the output. And these are the output current and voltage waveforms of reduced device count 9-level inverter. Figure 1 shows the output voltage of the proposed topology. In figure 1, the y-axis is represented with 9-level inverter output voltage and time is represented on the x-axis. The figure 2 and figure 3 shows the phase voltage and phase current of the reduced device count 9-level inverter respectively. And this is the THD of the waveforms of conventional cascaded H-bridge inverter. The THD value is 10.69 percentage. It is reduced, we can see that. And the comparison between conventional H-bridge inverters and reduced device count inverters is listed here. For conventional H-bridge inverter, number of switches and sources used are 16 switches and DC sources. We're coming to the reduced device count inverter, we using 12 switches and 2 DC sources. Switches are reduced by 4 switches and DC sources are reduced by 2 DC sources. Thus, we can reduce the switching losses and total harmonic distortion from conventional H-bridge inverter to proposed topology. The control technique used in conventional H-bridge inverter is multi-level carrier PWM technique, and in proposed topology, that is reduced device count inverter, novel carrier based PWM technique. The efficiency is higher compared to conventional H-bridge inverter and price can be reduced by using the less number of switches and DC sources. Coming to the conclusion, from this paper, we can get a succinct description of reduced device count 9-level inverter, and a detailed explanation of multi-level inverters has been discussed and reviewed. The proposed topology has many advantages over the conventional 9-level inverters. According to the section 1 in the paper, all the multi-level inverters have their disadvantages as mentioned: high switching losses, high cost, high THD value, and etc. These can be reduced in the proposed topology as shown in section 2 of the paper. Here control technique used is the novel carrier based PWM technique to get the 9-level output waveforms with low THD value. The author's only goal was to give a less number of components for a 9-level inverter and to improve the THD value of the inverter. Thank you.